For centuries, humanity has gazed at the stars, pondering the vastness of the cosmos. Our understanding of space is intrinsically tied to the concept of dimensions, length, width, and height, forming the very fabric of our reality. From Euclid's geometry to Einstein's relativity, these dimensions have been the bedrock of our scientific exploration, allowing us to map, measure, and comprehend the universe around us. But what if our fundamental assumption about space is flawed? What if, beyond our perception, space doesn't truly possess these familiar dimensions? This thought experiment challenges the very nature of existence, pushing the boundaries of our understanding and forcing us to reconsider the most basic tenets of physical reality. Imagine a realm where distance and direction, as we know them, are meaningless. A universe without up or down, left or right. How would laws of physics operate in such an environment? Our brains are wired to perceive three spatial dimensions. It's how we navigate, build, and interact with the world. Removing these dimensions would fundamentally alter our perception of everything. One way to approach this idea is through the concept of emergent dimensions. Perhaps the dimensions we perceive aren't fundamental but arise from more basic, non-dimensional components. Think of a complex pattern formed by simple data points. The pattern itself has shape and structure, but the individual points might not inherently possess those dimensional qualities. In theoretical physics, theories like string theory and loop quantum gravity hint at a reality where space-time isn't continuous but granulated, composed of discrete units. If these fundamental units lack inherent spatial dimensions, then our perceived dimensions might be statistical averages or collective properties of these more basic constituents. This idea isn't entirely new. Philosophers throughout history have questioned the nature of reality, suggesting that our sensory experience might be a limited interpretation of a deeper truth. Plato's allegory of the cave, for instance, proposes that what we perceive as reality are mere shadows of a more fundamental, unseen world. Fast forward to quantum mechanics, where particles exist as probabilities until observed, challenging our classical notions of definite positions in space. If a particle doesn't have a fixed location until observed, does it truly occupy a dimension in the classical sense? This opens doors to intriguing possibilities. Consider a scenario where information is more fundamental than dimensions. Perhaps the universe is a vast computational system, and spatial dimensions are simply emergent properties of data processing. This concept is explored in theories like the holographic principle, suggesting that our three-dimensional universe might be a projection from a two-dimensional boundary. If this were true, then the dimensions we experience wouldn't be inherent to space itself, but rather an interface generated from a deeper, less spatial reality. How would gravity work in a non-dimensional space? Einstein's theory ties gravity to the curvature of spacetime. Without dimensions, how would objects attract each other? Perhaps gravity would emerge from interactions between non-dimensional elements, like a collective pulling force arising from the fundamental connection between basic units. The concept of entanglement in quantum mechanics might offer a clue. Two particles can be instantaneously linked, regardless of the distance separating them. This suggests a deeper connection that transcends our conventional understanding of space and distance, hinting at a reality where spatial separation isn't fundamental. If space has no dimensions, then time, as we know it, would also be affected. Time is intricately linked to the progression through spatial dimensions. Our perception of past, present, and future relies on movement and change within a spatial framework. Without it, the flow of time could become an emergent property. Imagine time as a measure of informational change rather than a universal clock ticking forward. Each interaction or transformation would define its own temporal progression. This radical idea challenges our very perception of causality. If events aren't strictly sequenced by spatial distance, how do cause and effect relate? It leads to the possibility of a block universe where all moments in time coexist, and our experience of a linear flow is merely an illusion. Consider the implications for consciousness. If we exist in a non-dimensional space, could consciousness itself be a fundamental non-local phenomenon rather than confined to brains? This bridges into philosophical debates about the nature of mind and reality, suggesting that our individual experiences might be fragments of a larger, interconnected awareness. How would light behave? Light travels as waves and particles interacting with spatial dimensions. In a dimensionless realm, its propagation would be profoundly different. Perhaps light would be instantaneous, a direct transfer of energy between points without traversing intermediate space. challenging the universal speed limit. The very act of observation, which defines reality in quantum mechanics, might not rely on spatial separation but on informational interaction in a non-dimensional field. This thought experiment can feel unsettling because it dismantles the very framework we use to understand existence. But it's in these challenges that new discoveries are born. Could there be mathematical frameworks that describe such a non-dimensional space? Geometries beyond our conventional Euclidean understanding. Mathematicians have already explored concepts like topology, which studies properties of space that are preserved under continuous deformations, independent of precise distances. Perhaps a deeper topology, divorced from spatial metrics, could offer a language for a dimensionless universe. The universe could be characterized by its connections and relationships between entities, rather than their positions in an overarching spatial grid. This brings us back to the idea of a network. The entire universe could be a vast, dynamic network of interacting nodes, where dimensions are simply emergent features of its complexity. What would the Big Bang look like in such a scenario? Not an expansion in space, but an unfolding of relations and informational complexity. Instead of an expanding balloon, imagine a network growing in density and connectivity, where new relationships continuously form, leading to the structure we observe. This paradigm shift would force us to redefine concepts like locality and non-locality, observer and observed, and even what it means for something to exist. Experiments like those involving quantum entanglement are already hinting at a reality where locality, this idea of being confined to a specific place, might not be as fundamental as we once thought. If space has no dimensions, then everything could be, in a sense, connected, without the need for light-speed communication across vast distances. This could lead to a deeper understanding of phenomena like dark matter and dark energy, which currently defy our dimensional explanations. Perhaps these mysterious forces are manifestations of non-dimensional realities, acting on our perceived dimensions in ways we can only begin to comprehend. The idea of a dimensionless space isn't just a philosophical exercise. It could lead to entirely new predictive theories that better match observations of the universe. It challenges us to look beyond our ingrained human perceptions and consider realities that operate on completely different principles. This is the essence of scientific progress, daring to question the fundamental assumptions, even those that seem self-evident. While purely hypothetical, the what-if scenario of a dimensionless space opens up a cascade of possibilities, transforming our understanding of everything. It's a journey into the unknown, a voyage into the deepest mysteries of existence, where the nature of reality itself is up for debate. From the tiniest quantum fluctuations to the grandest cosmic structures, every aspect of our universe would take on a new meaning. We might discover that the universe is far more elegant and interconnected than our limited, dimension-bound minds currently conceive. This contemplation isn't about finding definitive answers immediately, but about expanding the scope of our inquiry. It encourages us to develop new mathematical tools and experimental approaches that can probe realities beyond our current observational limits. The universe is still largely an enigma, and humanity's journey to understand it is just beginning. Perhaps the greatest discoveries await those who are willing to question the most fundamental aspects of what they think they know. So what if space has no dimensions? It would mean a universe where location, distance, and shape are all emergent properties. A universe where connectivity and information take precedence, and our perceived reality is a sophisticated interface. It's a universe where the fabric of reality is woven from something far more subtle and profound than mere extension in three directions. And while it remains a thought experiment for now, it's a testament to the boundless creativity and curiosity of the human mind, always seeking to unravel the universe's ultimate secrets. The adventure of understanding continues, pushing the boundaries of imagination and reshaping our place within the cosmos.